second. Where's my damn? There it is. What time is it? Jesus. Oh, we just start. Also, is it just me or is this microphone not? Am I getting through the microphone or no? No? Yeah. I think this one is less sensitive than the others. Oh, also it was off. That would do it too. How about that? Am I coming through on this one? Still no? Still no? How about now? A little bit? A little bit? Okay, cool. Doesn't really matter, but we'll get started after a couple minutes more because people are all about. All right, apparently we're live. All right, so good morning, everyone. Sorry I couldn't handle the intro sessions. I had to finish some preparation stuff. Heads up that the presentation itself will be a bit light. This is a much more hands-on session. You should clone down or at least have some kind of working version of the backend from Tuesday. If you're not here Tuesday, go ahead and just clone down the repository. I'll share it in the Discord. Give me just 1 second here. Yeah, so clone that down if you don't have it already. It does include the Terraform configurations from yesterday with a couple of minor changes, but we're gonna all go over that. I'll have to run around and help you guys make stuff match up, but otherwise should be okay. So let's get started. We're gonna go into GitHub Actions. You learned about CI/CD in the previous session, is that right? Yeah. Okay. Let me actually. I am doing the right thing now. Oh no! Oh no! 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 I'm sorry, guys. This is the wrong damn presentation. CI/CD is next session. Holy crap! Or I'm sorry, GitHub Actions is next session. I'm sorry, everyone. I'm a mess this morning. We're doing CI/CD now. That's what we're doing. Okay. And Someone even highlighted it as the red thing. I'm so sorry, guys. Okay, here we go. I swear I know what's going on. But you should not believe me for a second. Okay. CI/CD. We're going to do CI/CD now, and we'll do GitHub Actions after this. So this is going to be a faster session. It's only going to be 30 minutes. So let's just burn through it, yeah? So we're going to go over what CI/CD is. We're going to give the context of the whole software delivery pipeline. Then we're going to cover what exactly is continuous integration, what exactly is continuous deployment, or continuous delivery. The definitions are all over the damn place. Then we're going to talk a little bit about application environments and how to manage that. And finally, the different methods of deploying stuff. Okay? Does that all make sense? Any questions about the agenda? I mean, no one, it's always like, well, you're going to tell us what the stuff is, right? Hopefully, yes. As usual, you know, I have not written a book on this stuff. And if you search for this stuff online, opinions are conflicting pretty much everywhere. So don't hold your opinions too strongly because there will be disagreements. You will probably disagree with me, and that's okay. But the important part is we all have the general idea of what's going on and what we're talking about. So first off, the software delivery pipeline. So wait, why did I choose this one? Anyway, so the idea is, you know, you plan requirements, and then, or someone ideally plans requirements for you, right? You build according to those requirements, you test it, right? And then, yeah, sorry, I chose the wrong image. I don't know why I picked this one. You test what you built, and then once it looks good, you know, you make sure that, you know, your product owner is okay with, or your product manager is okay with it. Maybe you test it with customers interactively if that's possible, all that sort of good stuff. And then you want to get it deployed, right? So you merge your changes with the main repository, right? Because you should be developing separately, unless you're doing Trump-based development, but that's a whole other thing. And then you, once everything is tested, once everything works well, once everything is merged properly and then tested again, then you go ahead and you deploy it, right? You release it to production, right? So it's like plan, implement, test, release, repeat, right? That's kind of the software delivery lifecycle, more or less, right? So everyone's more or less clear on that? Okay, not any rocket science there. But let's dive into like, what are CI/CD? What are those parts of this whole pipeline? So continuous integration. Integration in this case is the integration of new code into existing code, okay? So there's many different types of Git workflows, right? So you guys learned about Git on, I think, day 1. And, you know, with Git, you have different branches. And with different branches, often teams will have different branching strategies, okay? So these branching strategies, there's Git flow, there's GitHub flow, there's trunk-based development, there's all sorts of different strategies. But in the end, when your code, or when your new code gets merged with the existing code and becomes kind of the main line of development that other people are going to base their future code off of, right? This is integration. You have to make sure that the new stuff and the existing stuff all works together and shit doesn't explode. Okay, that's the goal. We do not want things to explode unless you're making an app that's supposed to explode, which could be interesting, but that's not what we're doing. So to make sure things work, what you want to do is once you merge, okay, ideally, or not ideally, in many branching strategies, when you're working on a new feature, you make a new branch, you develop your code in that branch, and then when you finish, you merge that branch back into the main line, the main branch, right? When you do this merge proposal, or this pull request, basically, that's when you should be automatically building your code if it needs to be built. If it's a language like Python, it's interpreted, whatever, it's fine. And you should test your code. Remember automated testing from day 1? How we pretty much haven't talked about it since? Yeah, you should be doing that. When we deliver to you guys the final version of the application code, it will have tests. We just haven't gotten there yet because this was all we're figuring out as we go. But then once you test your code, right, you should have some kind of test report, basically know that the tests either went well or went poorly. And then if everything looks good, then you merge it. Okay. So it's basically anytime you change something, test it, make sure it doesn't break. And if everything looks good, then you can merge your code. Very simple concept. There are tools to help you do this. So the automated testing, that's something you have to do yourself, right? With like PyTest or Selenium or Cypress or whatever tools you're using. But in terms of doing reporting, so in my team, in my department, we use CodeCov, which is a test coverage reporting tool. Actually, I can probably just show you guys real quick. How are we on time? Yeah, we're good on time. So let me just use images here. So CodeCov gives you a nice little test report. Where's the there we go. That's the one. There we go. Where basically you can see how much of your code is tested, how much of your tests pass, and what areas of your code still need testing. Okay, so I do recommend having a tool like this. I believe there's a free version of CodeCov, or it's free up to some number of users or something like that. Sorry? Awesome, thank you. It's free for public repositories. Thank you for checking. I only use it for private stuff, so yeah. But this is great to make sure that your testing coverage is good, because if you're doing CI, but your test coverage is like 5%, you're not really testing your application. You're just testing a tiny part of your application. So that is a thing. Yeah, okay. So once you have your pull request, it gets tested. Then once you've merged, you may or may not want to automatically deploy it. At the very least, you want to deploy it to your development environment, right? So that QA or whomever can start messing with stuff. Or if you are a backend engineer, like what we're covering in this bootcamp, so that front end can start testing against it. Although ideally, you should be providing your backend as a Docker image that they can just run locally for their testing. But, you know, it takes time for teams to mature. So at least start with a working development environment. And basically, you want, once code gets merged, it gets deployed. Or possibly, if you're super advanced, every time a PR comes up, you just spin up a whole new environment and deploy your PR to that environment for people to mess with and play with. But that's way more on the advanced side. Well, not way more, but you need to develop a certain level of kind of DevOps maturity within your team before you can do like dynamic environments and stuff. But it's certainly possible, especially with systems like Kubernetes, which you can learn about tomorrow. But continuous deployment is basically code gets merged, code gets deployed. That's it. Okay. Basically, you want to get your code up and running as often as possible with every change. And the reason for that is, if you can actually see your code running, you can see when it breaks. And that's it. If something breaks, you want to find out as quickly as possible. Okay, so that's basically the idea behind CI and CD. Does that all make sense so far? I know this is all very conceptual, but that's why it's a short session. Okay. The next session is going to be way more hands-on. But it is important to understand this whole thing. Now, in terms of continuous deployment, there's a lot of kind of ambiguity and debate around terms and definitions. It can also be called continuous delivery. But some people think that this whole broad process is continuous delivery, and then continuous deployment is actually deploying the software. Or another definition is that continuous delivery and continuous deployment are the same, but continuous delivery, you manually hit the button to deploy, and continuous deployment is it happens automatically. These are all different definitions, but the idea is the same. You're constantly deploying new code. That's the main thing. Okay? Questions? Cool. So you might be thinking, wait, if I'm deploying code all the time after just some automated testing, isn't that going to break shit? And yeah, yes, it is. So that's why we have this idea of application environments, where you'll do your development locally on your computer, right? But you want to deploy it to some environment to make sure it's up and running in a computer that's not your computer, right? Earlier, when we were going over Docker on day 2, right, we talked about, people saying, oh, it works on my machine, but we can't send your machine to the customer, right? So by deploying it to other environments and seeing it work and testing it in those other environments, basically other computers, you can make sure that it works on whichever machine, right? It's just another form of testing. So usually at a startup, you might have 2 environments. You might have like a dev, well, 3 technically. You'll have your local development environment, you'll have a dev environment, and you'll have a production environment, right? But as you mature, you probably want to add more environments, because when you start doing proper QA, you want a environment that's more stable than dev, because dev should be updating all the time, but an environment that's still not production, right? And QA will often do their work there. Because if QA is testing while you're deploying, you're going to mess up QA's testing. They have to restart their tests. They'll file bogus bug reports. It's just a bunch of wasted effort, right? So, and then you may also want an automated testing environment before QA, right? And so you may create a new environment for that, right? So over time, you end up having more and more environments, more and more copies of your code being deployed on separate infrastructure. And this roughly correlates to time and cost, right? The more time and the more you can afford to pay for this infrastructure, the more environments you can set up to have isolated deployments of your application to do various work against. Automated testing work, QA work, maybe user acceptance testing, all these kinds of things. Does that make sense? And everyone has an understanding of what environment is at this point? We've talked about it a lot through the bootcamp. Cool, I see a bunch of head. What's up?
Copies of project.
Yes. So for the benefit of online, the question was basically an application environment is copies of our product. And yes, copies of your product on different infrastructure. So for example, in my department, we have a dev environment where engineers can just like merge stuff freely and experiment, and front end and back end can interact and test stuff together. And then we have a staging environment where we do our QA. So once things are in a stable state, we push to the QA environment. It's the same application, just a different set of servers that we don't update the application as often on. So we push to our staging environment, QA does their testing there. And then once QA has said, okay, everything is good, we have no bugs that are like a critical system blockage kind of thing, then we deploy to production. It's a very classic style of deployment. Now, some people would argue that what I just described is not continuous deployment. Some people, or some teams, organizations, whatever, prefer that, your testing should be good enough that you merge code, or you submit a pull request, it gets automatically tested, the code gets merged, and then you deploy to production right away, right? That is a very good way to do things if you have a very strong team, if your automated testing is very good, if you don't have like a super critical application, right? Like we do cancer stuff. We don't want to mess up, right? But for other applications where they're a little more fault tolerant, right? So like a video game, for example, right? Video games make a lot of money. They're very important to a lot of people. But if your video game breaks, are people going to die? No, right? So, and even then, a video game is usually not just one system. You usually have a bunch of different systems, right? And if one of those subsystems fails, the game may still run just fine, right? So in these cases, it makes sense to actually do continuous deployment where like every time you merge code, it gets deployed to production, right? There are different situations where these things do and don't make sense. Anything with a very high regulatory environment, so finance stuff, medical stuff, you're not going to see automatic deployment to production. That is, no, right? The regulators would have your head. But, you adjust things to fit the industry that you're working on, the culture of your team, all this kind of stuff. Does that make sense? Cool. So deployment methods. So we've talked about, you do your automatic testing, you do your automatic deployment. But when we say deploy, what do we mean? So I described earlier, deploying to production. What is production? Okay, well, the simple definition is it's the version of your application that your end users can access, right? That is the production environment. But do you deploy to all of production all at once? Maybe not. There are other deployment strategies. So you can do something like a canary deployment where and it's been a long time since I've studied this stuff, so I might get my definitions confused. So if anyone remembers more correctly than I do, call me out. But you have a canary deployment where, let's say you have like 100 servers. You just deploy it on like 2 or 3 of those 100 servers. And then you monitor those 2 or 3 servers and see if anything breaks. And if it looks good, then you deploy to the rest, right? As far as I recall, I'm looking to Tom to see if he'll correct me if I'm not remembering correctly. That's a canary deployment. And the reason it's called a canary deployment is back in ye olden days, actually not even the olden days, even today, we mine coal. Good? Okay, thank you. Like humans, we mine coal, right? But coal is not the best for your health. Like breathing in coal dust will kill you. And there's other gases that can show up in a coal mine that will instantly kill you, right? So what coal miners would do is, rather than send a person down there, because if a person dies, like, that's bad, they would get a canary, a tiny little bird with tiny little lungs that breathes a lot really fast. If the air is bad, that canary is dead very quickly, okay? So what they would do is they would send a canary into the coal mine first, and if they keep hearing the canary like singing and flying and all that, after like 10, 15 minutes, maybe not 10, 15 minutes, I don't actually know how much time it takes, but after some time, then it's probably safe. And then the humans would go in, okay? Similar idea with a canary deployment. You deploy to just 1 or 2 servers, because if 1 or 2 servers fail, if you have 100 servers, that's not a huge deal, right? And then if those 1 or 2 servers look good after like an hour or so, okay, then you deploy the rest. Then you send in the humans. Okay, so that's where a canary deployment comes from. There's also blue-green deployment, where basically, rather than, if you're really confident, rather than just do 1 or 2 servers, you do like half your environment. You do a blue version and you do a green version, right? And you deploy the new version on blue, you leave the old version on green, and you see if everything looks good. And then over time, maybe you make green also match blue. You deploy the same version to both. And then you can kind of also leapfrog. So let's say that, you want to experiment with features more. You can deploy your new features here, leave your old features for a long time, and then compare the two and see if like, oh, does this feature perform better than this other feature? This is why if you've been on Facebook and maybe the version of Facebook you're looking at and the version of Facebook that the person next to you is looking at, they're different versions of Facebook, you notice differences. That's why. That's what they're doing. But there's a little bit of crossover between blue-green and A/B testing. Blue-green can be done for stability purposes to make sure things actually work. But if you do it at kind of the feature level, like I just described, you could argue that it's A/B testing, where you're testing, hey, does this perform better with users or does that perform better with users? So do people click this button more if it's green, or do people click this button more if it's blue? Like that's a legitimate A/B test that people spend a lot of money to do, right? And even those tiny little subtle differences in design can drive millions of dollars of difference in revenue because human psychology is weird. But A/B testing is a very, very common thing, especially in like marketing agencies or very, very large companies where they're trying to squeeze every penny out of us for their capitalist overlords. Anyway, so, and then I'm actually not familiar with recreate deployment or shadow deployment. And rolling update deployment is just you kind of like, update bits and pieces of your infrastructure as you go, that kind of stuff. So does that make sense for the different deployment methods? Cool. Canary, so in a less mature organization, you just deploy to production after you do your testing, right? But in More mature organizations, you'll do canary deployment, and then later you may start doing blue-green deployment. And when you, earlier I mentioned doing like automatic deployments to production, you'll often start doing canary deployments first. And then if you have a nice automated monitoring system where you can check to see if those canary servers basically have broken, or if their behavior differs a lot between them and the rest of the servers. If so, then you roll back. If not, then automatically deploy the rest of the servers, right? Same idea with blue-green. It's just instead of 1 or 2 servers, it's like half of your server set. Does that all make sense? Great. So this one was more of a conceptual one, but it's important to understand these concepts before we actually go into implementation. So any questions about the continuous integration, basically the automated testing and merging of code, or about automatically deploying applications? Any questions generally? Yeah. Why would you not just push to production? Why would you not just push? How many times has your code worked the first time you wrote it?
You test on a deployment and deadline, so it's going to be good.
Right. So you deploy.
So that you test this QA and
Yeah.
You test the production.
Yeah, but then you're not only deploying to production, you deploy to dev first.
Yes.
Yeah.
Yeah. I mean, you have several types of deployments. And I mean,
So why do like canary
Yeah.
deployments? Why do blue-green deployments? Because who's going to be a more effective test? What is going to be a more effective test run? You're like 5 or 6 QA people, or you're 500,000 or 600,000 users? Probably those 500,000 or 600,000 users, right? So the idea is testing at scale is always more effective. But the problem is you don't want to use your entire user base as a test, right? If only 1% of your users has a bad experience, that's a lot better than 100% of your users having a bad experience, right? So, and if you have like 1 million users, 1% is still 10,000 people. So if you deploy to 1% of your servers, those 10,000 people can test stuff and see if there's anything that your QA missed. And then if basically you see people complaining or you see your servers failing, then you can roll back the change. You only had 1% of your customer base unhappy as opposed to everyone. And then you can be like, yo, QA, we need to like do a better job, guys. Does that make sense?
So you partly deploy your public cloud. What was the time limit, like from one deployment to another deployment to new services to microservices to deploy? What's the time limit? I guess when you get the feedback, it's going to be like 1 week or 2 weeks for deployments, or how is it?
That's going to vary a lot.
Yeah.
It can vary based on how large of a change you're trying to do. Like if you're changing the color of a button, whatever, man. Give it like an hour, see if you can see the differences, then it's fine. If you're changing your underlying data model, which has a cascading effect on like 5 different systems, yeah, maybe let it sit for a few days and make sure that it still works, right? And it's also depending on things like your user traffic, right? So if you're getting thousands or millions of users per hour, right? You maybe only need a couple hours of feedback, right? But if you have like 1,000 users a day, yeah, you're going to need a couple days to sit and watch it. So it's all kind of variable. Does that make sense?
Thank you.
Other questions? That was a good one, or good pair of questions. Yeah.
Actually, I have not a question, but actually I have not like a question, but more like what to add probably.
Go for
I
it.
think like for the types of deployments, I think it depends on what you deploy, right? For example, like if you are doing the backend deployment, then probably canary deployment is not really possible. And if you are doing the mobile application deployment, then it's something different, like where you can do it. Is it a canary deployment or A/B testing? Yeah, and So, and the reason why that there are that many types of deployments is that like not everything matches your application basically. Right?
Mhm. Yeah, so canary deployments can be complicated for backend because if your backend API is different from one server to another, your front end is going to break, right? But what you can do, and this is, like I said, this is for a much more mature DevOps environment. What you can do is have your basically set them up on a different domain. So they're technically a different environment, but you can have like canary.whatever.com or something like that, and then have some random amount of your front ends point to those backend servers, right? So you could do that. But yeah, there are ways to do it. It's just more complicated. Again, that's going to rely on you having a much more mature DevOps and engineering organization generally. But yeah, it's definitely going to depend on the type of application you're deploying. So yeah. All right. Anything else before we end the session? Excellent. Let's take a 4-minute break. Let's come back here at 11:05 and then we'll start the next session. Thank you guys.